Our universe is a vast and mysterious place, filled with wonders that boggle the mind and challenge our understanding. From the smallest particles to the largest galaxies, the cosmos is a tapestry woven with threads of both known and unknown elements. We have made incredible strides in understanding the cosmos, but some secrets remain elusive. Despite our advancements in technology and knowledge, there are still phenomena that defy explanation, leaving scientists both frustrated and fascinated. One of the biggest mysteries is dark matter. This enigmatic substance makes up about 27% of the universe, yet we know so little about it. Unlike the matter we are familiar with, dark matter does not interact with electromagnetic forces, making it invisible and undetectable by conventional means. It's an invisible force that holds our universe together. Without dark matter, galaxies would not have enough mass to hold themselves together, and they would simply fly apart. This unseen glue is essential for the structure and stability of the cosmos. We can't see dark matter. We can't touch it. It doesn't emit light, reflect light, or absorb light. This makes it incredibly elusive and difficult to study directly, yet we know it exists. How? Because of the effect it has on the things we can see. The gravitational pull of dark matter affects the motion of galaxies and the bending of light, phenomena that we can observe and measure. How? Because of the effect it has on the things we can see. The gravitational pull of dark matter affects the motion of galaxies and the bending of light, phenomena that we can observe and measure. This indirect evidence is crucial in our quest to understand dark matter. It's like a ghost tugging at the fabric of space and time. This invisible hand shapes the universe in ways we are only beginning to comprehend. The study of dark matter is not just about understanding a single component of the cosmos. It's about unlocking the secrets of the universe itself. Dark matter doesn't emit light. It doesn't reflect light. It doesn't absorb light. This makes it incredibly difficult to detect. Traditional telescopes and detectors are useless in the hunt for dark matter, forcing scientists to develop innovative methods and technologies to uncover its secrets. This makes it incredibly difficult to detect. Researchers are using everything from underground detectors to space-based observatories in their quest to find direct evidence of dark matter. These efforts are pushing the boundaries of science and technology, leading to new discoveries and advancements. Yet, its gravitational influence is undeniable. The way dark matter bends light and affects the motion of galaxies provides compelling evidence of its existence. As we continue to study these effects, we move closer to unraveling the mystery of dark matter and understanding the true nature of our universe. Imagine a spider web. It's delicate, almost invisible, yet incredibly strong. In the early morning light, dewdrops cling to it, revealing its intricate structure. You can't see the web itself, but the dewdrops make it visible. This is much like how we perceive dark matter in the universe. The dewdrops cling to the web, just as galaxies and stars cling to the gravitational pull of dark matter. We can't see dark matter directly, but we can observe its influence. That's how we detect dark matter. It's the unseen force that shapes the cosmos. Much like the spider web shapes the pattern of dewdrops, we see its effects on visible matter. Galaxies, stars, and even light itself are influenced by this mysterious substance. Galaxies are spinning faster than they should. According to the laws of physics, they should be tearing apart, but they aren't. The only explanation, a hidden mass, much larger than what we can see, is holding them together. This hidden mass is what we call dark matter. That hidden mass is dark matter. It's like an invisible scaffold that holds the universe together, providing the necessary gravitational pull. It acts like an invisible glue. This glue binds galaxies together in clusters, ensuring they don't drift apart into the vast emptiness of space. It binds galaxies together in clusters. These clusters form the large-scale structure of the universe, creating a cosmic web of interconnected galaxies. Without dark matter, the universe would be a very different place. Galaxies would not have formed, stars would not have clustered, and the universe as we know it would be unrecognizable. Dark matter is truly gravity's silent partner, shaping the cosmos in ways we are only beginning to understand. For decades, scientists have been trying to detect dark matter directly, They've built underground detectors, they've used powerful telescopes, but dark matter has remained elusive. These traditional methods have limitations. They rely on hypothetical interactions between dark matter and normal matter. Interactions that are extremely weak and difficult to detect. But the game is changing. A new player has entered the field. Artificial intelligence is revolutionizing our search for dark matter. Artificial intelligence, or AI, is transforming many fields, and now it's being used to tackle one of the biggest mysteries in astrophysics, dark matter. AI excels at pattern recognition. It can sift through massive datasets that would take humans years, if not lifetimes, to analyze. AI can spot subtle correlations and anomalies that might hold the key to understanding dark matter. Section 5. Unmasking Dark Matter with AI. AI is already making groundbreaking discoveries. In the realm of astrophysics, AI algorithms are being employed to sift through vast amounts of data that would take humans years to analyze. These algorithms can identify patterns and anomalies that are crucial for understanding the universe. By analyzing gravitational lensing data, AI has helped create maps of dark matter distribution in the universe. Gravitational lensing occurs when massive objects like galaxies bend the light from objects behind them. This bending effect can reveal the presence of dark matter, which doesn't emit light but has a gravitational influence. AI is also being used to analyze data from particle colliders. These colliders smash particles together at incredibly high speeds, creating conditions similar to those just after the Big Bang. The data generated is immense and complex, but AI can help make sense of it. The hope is to find evidence of dark matter particles. These particles are thought to make up about 27% of the universe, yet they have never been directly observed. AI is helping scientists narrow down the search by identifying promising signals in the data. Particles that have so far escaped detection. The elusive nature of dark matter makes it one of the most intriguing mysteries in modern science. AI's ability to process and analyze large data sets is providing new avenues for discovery. These are just a few examples of how AI is revolutionizing our understanding of dark matter. As AI technology continues to advance, it holds the promise of unlocking even more secrets of the cosmos, potentially leading to groundbreaking discoveries that could change our understanding of the universe. Section 6. A new era of cosmic exploration. The use of artificial intelligence in dark matter research is still in its early stages, but the potential is enormous. As AI algorithms become more sophisticated, we can expect even more groundbreaking discoveries. AI is not here to replace scientists. It's here to augment our abilities, to help us see the universe in ways we never thought possible. Section 7. Rewriting the cosmic script. The implications of these findings are profound. Dark matter makes up the vast majority of the universe's mass. Understanding dark matter is crucial to understanding the universe's evolution and its ultimate fate. Will the universe continue to expand forever, or will it eventually collapse in on itself? The answers to these questions may lie in the secrets that dark matter holds. Section 8. The future of AI in unraveling the universe's mysteries. The marriage of artificial intelligence and astrophysics is just beginning. As we develop even more powerful AI tools, we can expect to unlock more secrets of the cosmos. AI is not just a tool, it's a partner in our quest to understand the universe. A partner that can help us see beyond the visible and comprehend the unimaginable. Section 9. The dawn of a new cosmic era. We live in an extraordinary time, a time when artificial intelligence is helping us unravel the universe's greatest mysteries. The discovery of dark matter was just the beginning. Who knows what other secrets the universe holds? And who knows what other tools we will develop to unlock them? One thing is certain, the future of cosmic exploration is bright.